Okay, people, this is like the greatest rhombus problem on the planet. All right, so what do we know? This is a rhombus. And what's the goal here? Well, we want to find the perimeter of the rhombus. That's about it. Well, to find the perimeter, it would be nice to know one of these sides. Why just one? Is because in a rhombus, all four sides are congruent. So we just have to find one of the sides. So what do we know so far? It looks like AC is 6. Well, if that diagonal is 6, what is the first thing that pops into my mind? Well, since we know the diagonals are being bisected, they bisect each other. Those two segments are 3 and 3. All right, what else do we know? Well, DB is this other one in here. And so if that's 8, the same exact property tells us the diagonals bisect each other. That's 3 and 4. Why would I want to chop them up into little pieces? Well, if you truly understand how the diagonals create triangles within a rhombus, you'll see that all 4 of these triangles are congruent. Well, not only are all 4 triangles congruent, they happen to be a type of triangle which is going to be very, very helpful here to find the perimeter. One of the properties of a rhombus is the diagonals are perpendicular to one another. Therefore, they create 90 degree, they are right angles. Therefore, they are 90 degrees. So as soon as I see, as soon as I use one of these triangles, and I'm going to use this one over here, I can use the very famous theorem called Pythagoras to solve for the missing side. So in this case, if you can see it, we have 3 squared plus 4 squared equals x squared. Why did I put the x squared all by itself? Well, it's the hypotenuse. You may be wondering, why did I use that triangle? Well, I just mentioned a moment ago that all of these triangles are congruent. It didn't really matter which one I use. So when you solve for x in here, x turns out to be 5. Are we done? No. So if that one's 5, it turns out all of these sides are 5 because that's one of the properties of a rhombus. So 5 times 4, the perimeter of this rhombus is 20. All right. Thanks for listening, and see you soon.